Hey guys, let's continue in our review here. All right, so it's we kind of reviewed our angle relationships, and now let's work on our problem. So it says, suppose L and M are parallel. So this is the space between L and M, and this is my transversal there, right? Maybe a little thinner line for my transversal. Suppose L and M are parallel. What is the measure of each angle if M is 138? So the measure of angle, excuse me, I think I said M. Angle 2. So the obtuse angle is 138. That means every acute angle has to be 180 minus 138. So I get 42. For any acute is 42 and any obtuse is 138. And let's just double check by adding those back together. Yep, okay. So angle 1 is acute, so that would be 42. Angle 3 is acute, so that also would be 42. And angle 4 is obtuse, so that would be 138. Okay. Now, question 9. If angle 1 is equal to 3x minus 3 and angle 5 is equal to 7x plus 23, for what value of x are the two parallel? So if we went backwards and said they're not parallel, or at least we don't know it yet, what would make them parallel? So let's look at angle 1 and 2 again. So using the same picture, I'm going to look at angle 1 and angle 5. So angle 1 is acute and angle 5 is obtuse. So those are same side exterior angles. So those are same side exterior angles. So we know that these angles would have to add up to 180. The measure of angle 1 plus the measure of angle 5 would need it to add up to 180 in order for them to be parallel. So let's add those two together. All right, so 3x minus 3 and 7x plus 23. All right, so I need a little space to write my question. So this is question 9. Again, you might have some room on the margin, or you might be doing this on another piece of paper. So 3x minus 3 plus 7x plus 23 adds up to 180. So here we can combine these, right? And we can combine these. And now we have a nice equation here to solve. So if I subtract 20 on both sides and divide by 10 on both sides. Okay, so I showed my work. It says what value of x would make them parallel, and I found out the x would need to be 16. Now make sure to get all your credit. You don't just write the answer to each question on here. You got to show some amount of work on a piece of notebook paper or out on the margins. All right, let's look at number 10. It says, let's reason the transversal that intersects two parallel lines form corresponding angles with the measurement, this expression, and the measurement, this expression. What is the measure of each angle? So pay attention here. I'm not solving for x, I'm solving for each angle. So I will have to solve for x first, but then I'm solving for what is the measure of angle 1 and what is the measure of angle 2. Now let's look back in our notes. We said that corresponding angles are congruent, right? So I'm going to put these together. They should equal each other because that's what congruent means, equal in measurement. So let's just jot down these expressions, 3x minus 7 and 2x plus 12, and show our work here. So question 10, we have 3x minus 7 and 2x plus 12. We know that these would need to be equal to each other because corresponding angles are congruent. All right, so if I subtract, I get all of my x's on one side, so up here. Right? And then I gotta get x by itself on one side, so let's get the 7 over to from the left to the right. And I'm left with 1x and 19. But remember, I'm not done. That's just the first part of the problem. Now I've got to plug it in. So I got to go in here and I've solved the mystery of the x. Angle 1 is still 3x minus 7, but we now know that x is 19. All right. So that would be 57, take away 7, I get 50. Okay, now I'm going to do the same thing to the other angle. 2x plus 12, and I know x is 19. And I get 50. Okay, and this again is what I'd hoped for because they're congruent. Corresponding angles are congruent. So we got 50 for angle 1 and 50 for angle 2. Right? That's what we got for each one. Cool. All right. Now we're ready to go to the next page. Let's see. Lesson 2-3, parallel lines and triangle angle sums. Okay, so a lot of people like this section. We said the interior and exterior angle measurements of a triangle have the following properties. The sum of the interior angles, so this angle 1, 2, and 3 would add up to 180. We also know this exterior angle would add up to these two remotes. All right, so we could call that maybe the fourth angle. These two angles would add up to this fourth angle out there. So we got to work through both of those. So if we notice here, for example, the first example, it says, what is the measure of angle 1? That's definitely our exterior, and these are the two remotes. So we can just add these together. 36 and 127, 13, 163. And that's why they got 163. They merely added them together. So they already kind of worked through that example for us. But again, it's good studying for the test to read through that. All right, now we see in question 11, we know two of the angles and we have one missing. So that's perfect for us. We can just add those up. So 50, 74, and x. 50, 74, and x. They're all the angles of a triangle, so we know they all have to add up to 180. All right, so we're just going to solve for x. And I get 56. 56. Now to double check our work, we can add these up together. So yeah, I think that works. All right, x is 56. Now let's go to the next one. Our formula says the two remotes add up to the exterior. All right, so x would be equal to the two remotes added together. Nice, okay. Now let's see, 13, the two remotes add up to the exterior, but that's 103 and x have to add up to 53. So 103 and x have to add up to 152. So I get 49, and again, you can double check your work. Is 49 plus 103? Yeah, yep, that looks right. Okay, last one like this. Do the two remotes add up to the exterior? So here's my two remotes and my exterior. So does x and 40 add up to 66? We say yes, based on their locations. So if I rewrite this, I get x is equal to 26. And again, I can substitute that in and just double check my work. Is 26 and 40 add up to 66? Yes, it does. Okay. Last one on this page, and then we'll move to the last page. Make sense and persevere. During a storm, a tree is blown against a building so that it forms a triangle. So here's my building, and apparently a tree blew against it. So here's my tree limb. Kind of looks like a skinny Christmas tree. So in a storm, a tree blew against a building so that it forms a triangle with with remote interior angles of 90 and 52. So I'm thinking this is 90 and this is 52. What is the measure of the corresponding exterior angle formed by the leaning tree? So this is our exterior angle here. So we take a look here. Didn't we say that two remotes add up to the exterior, right? So the two remote angles, 52 and 90, have to add up to the exterior angle, which we don't know, but that's what we're solving for. So we can call x whatever it is we're solving for, and we get 142 for the exterior angle. Nice work, guys. Check out the last